All right, I've started the recording. Welcome to our CIS 117 Week 6 Hangout. And Wendy, before I started the recording, asked an excellent question. And that is, okay, we've got these joins and we've got these subqueries. How do I know? How do I just know by looking at a problem when I need to do one and when I need to do another? And the first thing is let me concede that there is some overlap. So do you remember when we were working with the exists operator or the any or the all operator? And we said, you can use this instead of a join. I mean, for some circumstances, it's like giving you a join. So logically, there's some overlap.
I tried a couple of different scenarios where I was trying to use the in and the exists. So, yeah.
Probably the easiest way is, before we even think about the subquery, is let's start by, especially if you're a visual person, look at the data model and let's see if the data model will tell us whether a join is where we want to go. Okay, so
That's good.
Let's take a look at one of the actual exercises here. Exercise number 3. Everybody struggles with exercise 3, and let's just work through it in its entirety. So exercise 3 said, let me go ahead and increase the zoom a little bit for.
The first part was easy for me. It was B and C that I bombed.
Okay, but that's the thing. Let's find out where the disconnect is there between the point that was easy and the point where the bombing happened. Okay, so it says, using the CIS 117 database, create a view. We're going to name it item gross profit. It consists of the item ID and a calculated field indicating the gross profit earned by the total sales of each item. Okay, so let's just start by, this is the CIS 117 database. Do I have an ERD on that we can just look at? Oh, that's the 107. Let me find the 117. Yeah, so here's a PNG of the database, okay? And this is very helpful. So I have 1, 2, 3, 4 primary tables. And so I see that one customer has 0 or many orders. 0, because how can it be a customer 0? Well, he's just signed on to the website. He's going to buy something, but hasn't actually bought anything yet. So the customer exists. They filled out their stuff because they're in the process about to buy something, but no orders. Okay, so once they have an order, they can have one order, they can have many orders. Okay, in each order, we can have one or many details, which is to say, a lot of times we don't call this order details. We might call it line items, right? Because on the order, I would like 3 of stock number 5170, and I want 7 of stock number 8182, and I want 17 of those wonderful stock number 3133s that you have on sale. And so, in that are the order details, and that's going to tell us basically what it's going to tell us what the order number is, what the item number is. Okay, so it's sort of a compound key. It's a bridging table. And why is it a bridging table or an associative table? Because one order can have one or many items, and one item can appear on one or many orders. Well, that would be a many-to-many relationship. And anytime we have a many-to-many relationship, in this short course, the CS 117, we don't spend a lot of time talking about database design. We're working with database mechanics. If you take a longer course like the CIS 107, or if you go on and take the advanced SQL programming, CIS 231, where you get into more of it, you're going to touch on more of the design, and we're going to discover that one of the things that we do, if we have a many-to-many relationship, think about the complexity. 1 to 1 is 1. 1 times 1 is 1. 10 by 10 would be 100 elements of complexity. 100 by 100 is now, oh my gosh, that's 10,000 items of complexity. If we could reduce this to a pair of one-to-many relationships, even if it's 100 things related to 100 things through one, then it's 100 by 1 is 100, 100 by 1 is 100. That's 200 items of complexity rather than 10,000. So you can see just sort of intuitively, without my getting deep into the mathematics, that two one-to-many relationships are way better than a many-to-many relationship in terms of potential complexity.
Right.
And if you will take it on faith or an intuitive feel that complexity equals performance, or the inverse of performance, the more complex, the less well something is going to perform, and performance is really important to us. You kind of, this is an intuitive, sort of an intuitive semi-mathematical way to feel into the fact that we want this associative table that resolves one order can have many items on it. One item can be on many orders, and so we have this order details, or a lot of times naming convention wise we would call this order items table. We would combine the two parent tables. Names, excuse me, throat is very dry. All right, so looking at this, let's get back to our original question. And where was the Word document that had our 117 instructions? Okay, and so they're saying we'd like to create a view called gross profit. It consists of the item ID and the calculated field indicating the gross profit. Okay, so what table has here the item ID? Well, we could find the item ID in the bridging table, order details, and we could find it in items. Okay, where do we find gross profit? Well, it's a calculated field. What is the formula in business to figure out the gross profit? If we simply subtract what I sell it for minus what it cost me, that's the gross profit. Why isn't it the net profit? Well, there's other costs of doing business. I got to pay the help. I got to keep the lights on. There's load and other factors.
Yeah, overhead.
Taxes, all the rest of it. But at a gross level, the simple cut, before I take out all the extra things, the gross profit is if I simply subtract the cost. Now, can I get the cost from one table and also the unit price from one table, and I can get the item number from that table?
Yep.
So do I need more than one table? No, it's all going to be on the items table in order to do that. So if it's all going to be on the items table, do I need a join? Only if I was going to have to join it to itself, and self joins are rare.
Okay, good.
And just to
still confuse me.
Just to refresh our memories, why would I have, the most common reason for having a self join is when an entity has a relationship to itself. Well, what does that mean? Think of it this way. The classic is all employees have a supervisor, but all supervisors are also employees.
Right.
And so if I am an employee, how do you know me? By my employee number. If I want to uniquely identify my current supervisor, what do I give you? His or her employee number. So an employee table would have a self join. The employee who is my supervisor also lives in the employee table. So for every record, I would have the employee would have the employee's own ID, and then it would also have supervisor ID. And the supervisor ID would be identical to another employee ID that exists somewhere in the table. So I guess the only one that might have no employee or might have no supervisor is the owner of the company. Or you could, by convention, say, hey, the owner of the company is his or her own supervisor. Right. Is there any reason you can't say my employee ID is number 1 and my supervisor ID is number 1? I'm self-supervised. If you didn't create a business rule against it, well then yeah, you're self-supervised. You probably only ever want to have one of those, but that would be okay. So self-join. So I think we've eliminated in this case. There's nothing here in items where items are going to have a self-join relationship. So we've kind of talked through the fact that we're not using a join here. Now the question is, do we need a query? Okay, a subquery. And what is the reason for a subquery of something? Well, we use subqueries for any, we use them for all, we use them for exists, and then we also use them to compare with a value derived from a table. So in other words, if I wanted the average cost of all the items and I wanted to know, you know, is a given item more or less than the average cost, then I could compare that using a subquery, right? Okay, so that would be an example. Am I doing anything like that in this case?
Okay, you just blipped out for a few seconds.
Sorry, I'll repeat that. So one of the reasons we would use a subquery, and we've already decided this is all on one table. One of the reasons we might do that is, and let's go ahead and explore that rather than just talking through it. Let me bring up SQL Server, and let's say use CIS 1.7 DB and select star from items. Okay, so one of the things that might be useful to know here is in this list of things from items, tell me what the where artist equals umami. Okay, so now I'm just focusing on, oh, got to put it in quotes, Beck. String literals in quotes. Okay, so here's the things by umami. Now, what if I would like to know how the price of umami compares in each of their records to the average price for all of the things in the database.
Mm-hmm.
Select star from items. Okay, that's everything. But I only want, let's say, I'm focused on price.
So you're gonna have to do an average.
Unit price. So here's all the unit prices. You see, I'm picking away at it piece by piece.
Okay.
And here's the average price, and that's $16.52. And here, what I would like to have is I would like to know, how does umami compare to that? And I would like to not have to recode this by hand each time. So I don't want to have to calculate 1652 and then, so I could say select star, comma, and then just put in 1652, right, in there, and run that. And no column name 1652. But that's not really very useful because over time, tomorrow I buy a bunch of new stock, new inventory, and the average has changed. Okay, so this would be no good. So what I would really like to do is I would like to have that be dynamically generated.
Right.
And this is where we can use a subquery. Okay, so how do we get that out of our subquery? So subquery is always going to look like wrap it in a hug. So there's our subquery, and what do we do with our subquery?
Goes in the where clause, right?
Well, depends on what we would like to do with it. So where do you want to put it? Do you want to know it for just umami? Do we want to know it for everybody? And is this any? Is this all? Is this exists?
So you want to compare umami, the one, against the rest, right?
Mm-hmm.
Okay.
So we want to get this 1652 into this as a field. So we need to have a field, and where do we get that?
Calculate it and then name it.
Well, here it is. So it's
Right.
calculated,
Right.
and we could name this as my num. Okay. So I could take this thing and can't do it on its own and give it an
Right.
alias. I need to make that as part of it. But anyway, you could see where we're going with
Right.
wrapping this into a subquery to make the comparison. And we can also see, we don't need to do this heading into it as a join. Let's get back to our original question. So here's our data model, and the original question is we need this view gross profit. And so let's work on that for a moment. And let's start with a select star from items. There's everything. And we want to know the gross profit. And so one of these fields that we don't have yet is going to be gross profit. And we're going to call that, let's see, it's going to be the unit price minus the cost. Let's wrap that up. And that would be the individual gross profit. For selling one. But here's where it gets a little insidious and more complex, because in number 3, again, what was the original question being asked? Where's our Word document? Create a view named gross profit. It consists of the item ID and calculated field indicating gross profit earned, by the total sales of each item. So this is not assuming that we magically sell exactly one of everything during a time period. We need to get the actual sales. Here's where we need to go back and look at how do I get,
count, right?
how do I, well, that's true. A count and a total, and then, depending on what we want to do with that, are we doing averages, we doing sums, we doing counts? But let's take a look at that. How do I know how many of each item I sold? Items doesn't tell me how many were sold.
You have to go to order quantity.
Okay. So
now you do need to join a table.
Now I have 2 tables at least that I need to deal with. As a matter of fact, in order to get this, what tables are going to be involved in order to give me that? I'm going to have, let's see, at least 2, maybe 3 tables. Order details and items, right?
Right.
There's my 2 tables. If I run that, I've just committed a classic mistake. Do you really believe there's 680 rows?
No.
They're uncorrelated, right? Because I didn't provide, I got a Cartesian product because I didn't say, I didn't put either an explicit or implicit join clause. If I don't actually use the word join, it's implicit. I like using the implicit joins. They're my favorite. There's either way is fine. Okay, whatever.
It's clear. Yeah.
It works for the way my mind works. Some people are much better using the explicit join statement. That's fine too. And I'm pretty sure every major database out there supports both. So we're going to have order details dot something is going to equal items dot something. And if we go back and look at order details and items, the thing that they're going to be linked on, the foreign key foreign key um, uh, primary key relationship is going to be on item number. Okay, that's one of the things that's really handy about having keeping the diagrams around. So item ID and item ID, and now have I got the join correct? 68 rows. Now I'm believing it. 68
Right.
rows. I believe I have 68 records in there. It passes the sanity check, but this is still giving me everything. And what was the requirement we're trying to meet here? It says the gross profit consists of the item ID and a calculated field indicating the gross profit earned by the total sales. Total is also sum, the sum of sales of each item. Okay, so let's add in that extra calculated field. I'll leave everything else in place. We'll clean up in a minute. And we want it to be the unit price minus the cost. Okay, but is that enough? I need to multiply that by how many were actually ordered. Okay, where can I get the quantity of things that were ordered? Is that in order details? Yeah. Times the order quantity. Okay, now we're close, but still no cigar as yet. Let's take a look at what this has given us. Because how can this be right and there's 68? This isn't looking right. What I need here is I need to get the sum of these. And we're going to give that an alias name. It said call it gross profit. And let's see, order details, order ID is invalid, and the select list
Need the group by, don't you?
contained in either an aggregate function or a group by clause. There you go.
It always gets me.
Right, so this is fine if all I want, if I don't have the sum on here, so I'm not doing the aggregate, that's fine. But if I want to get totals grouped by what? They're going to be grouped by the item ID. Okay. So if I make that the aggregate, I need to also add group by item ID. Now, item ID, is there only one place where item ID can come from, or are there two?
No, you're going to have to qualify it.
So if I do this, it's going to say, hey, that's ambiguous. And it's going to get upset. Let's try it. Nah, ambiguous. I don't know which one you mean. Okay. Let's grab items.item ID. Can I do that? Okay.
No, because
Still
you have to add. Yeah.
So it has a whole bunch of things that in the list that are not contained because why? All of these fields are not there.
Right.
Okay, they're not part of the aggregate function, and so I need to trim that down and say, oh, you know what? I need items.item ID. Now, is everything in the group or the aggregate function? Yes, it is. Everything is now going to be in the group or the aggregate function. Now it should work. Let me make a liar out of me. Yay. Okay.
Ugh, wow.
So now I have the individual items and what the gross profit was for each. Okay. Having created that select query, I am now ready. That's 99% of the battle is getting the select query built.
Yeah.
Once the select query is built,
it's easy to create the view. Yeah.
We can very easily create the view. Let me go see if the view. So I already have that view out here, and so it's going to error if I try and create it. So
yeah.
I'm just going to. I could either issue the drop command here, or the easy way. Since
that's okay. Yeah, I get that.
Is I'm just going to go ahead and drop delete the view. Bam, it's gone. Okay, And so now if I come up here and say create view item gross profit as the following, I should be able to execute it once correctly. Create view must be the, oh,
Yeah.
it doesn't like that in the batch. There
Yeah.
we go. There, okay, now it went successfully. If I try it a second time, it's going to go, it already exists. Okay, I don't need to do it a second time. If you really want to run it a second time, just come over here and drop it. There's also a lot of query dialects, SQL dialects, so create or replace. And, so you can come up here and say create or replace. I don't recall. I'm teaching two dialects of SQL this term. I don't remember whether Transact SQL supports the create or replace, but you can look that up on Google pretty quickly. I think that Oracle and MySQL do. I think that Transact SQL does not, and you have to just tell it, if exists, view.
I haven't run across replace in the Transact documents I've been looking at. Yeah.
Yeah. I think you usually just code it as if it exists, delete, drop it, and otherwise leave it alone. Or you can come do it with the GUI. If we're building scripts that need to be run and rerun, we would put the clause in here that says if it exists, drop it. Otherwise, just create it. Okay, but now we should have the view created, and now we're ready to move on to the additional questions. So the next question. Actually, this one's pretty simple. It's telling us we want to do
thanks. That was hard for me.
Well, okay, it is the first time, but what we're doing is we're going to select the item ID from the item gross profit, where the gross profit is equal to, oh, look, here's the subquery we were talking about. It's equal to a specific number, okay? And this is going to be the maximum of the gross profit. Now, let's break this down.
Yeah, because that's where I got totally lost. I got the first two lines, and then I went, what?
Okay, so I've just broken this up. So here's the subquery. What is it we're looking to compare on? We're looking to compare in part B on the maximum gross profit in this view. Item gross profit is the view. Gross profit is that calculated field in the view. Let's run that. Okay, so at the current point in time, it's 8164. We could just replace this entire expression with 8164. The problem is, as soon as we get some more inventory in and change things, that number is no longer going to be 8164. So we use this expression so that it will dynamically be whatever the correct number is. Right now, it happens to be 8164. Okay, what do we want to do with this 8164? We would like to select item IDs. So let's break this out for just a minute, and let's actually put the 8164 in there, okay? We'd like to select item IDs in the view where the gross profit is equal to the highest. It's that one. Well, item number 1 happens to be the winner, okay? But again, that's going to change over time. So instead of hard coding 8164, we now wrap this whole expression in a hug, right? When I put it in parentheses, I call it wrapping it in a hug. So this whole expression that is going to dynamically generate 8164, and this says select the item ID from item gross profit, where the gross profit is equal to the number that happens to be at the current time the max gross profit in there. And now when we run it, there it is. Okay, so let's run the whole thing. There it is.
Yeah, it's like all that work for that little thing. Yeah.
Well, yeah, but it's only a one simple number. Yeah, but so is the winning number for the lottery. Just a simple string of numbers, So, but if you could generate it, how much work would it be worth to you to generate that one simple number? Yeah, a lot.
True. Yeah.
Okay. So now what we'd like to know is, what does the database actually do? And one way to look at that, thank you, is if I highlight this and I say, show me the estimated execution plan. This is the algebraic logic, the algebraic or relational logic it actually goes through. There's a select, costs you nothing. There's a top filter, costs you nothing. because they really aren't doing anything. There's a sort that occurs. There's a filter that costs you nothing. There's a stream aggregate, costs you nothing. Nested loops, 14%, and you can see where your performance is here. Isn't that kind of interesting? The plan tells you.
I've never seen this view before.
But yeah, the more interesting thing here is this tells us exactly what the query logic is that's going to execute there. There's the
now, how did you get that again?
So what I did, and kill that, is I came over to this query and I said, show me the estimated plan. Now the estimated plan.
Okay, you just blipped out again. You're frozen.
Sorry. Okay, so let's see. Can you hear me now? Can you hear me now? I'm not sure if this is on my end or your end, so I'm not sure if the recording's okay and you can't hear me, or if nobody can hear me in the recording. Wendy, let me know when we're back.
It's
all righty. So for some reason, my system dropped the connection. Are you able to hear me now?
Yeah, I can hear you. I can see you. I just can't see the screen.
Yeah, I just need to go and.
It's like you sounded like Rain Man there for a while.
All right, there we are. And I'll check, and yeah, okay, so the recording has resumed. So anyway, if you highlight a query and right-click it and say, show me the estimated execution plan. It will show you what the query optimizer expects to do in processing this.
I like that. Yeah.
And in a more advanced class, we would look not only at the estimated plan, we would actually trace the actual plan, and we would say, hey, if we see a lot of for example, a table scan here, this is a clustered index scan. Clustered index scan, that's good. That means it's using indexes to do the work, and looking things up on an index is always much faster than having to go through a table scan, which would be looking at everything in the table one at a time. And you may have 1 million or 10 million or 50 million rows in that table. Okay, so a clustered index scan is good. If we saw it doing table scans, we'd go, oh, let's see, let's think about this. On what field could we, so if we're sorting our list of employees by last name and first name, and there's automatically a unique clustered index on the employee number, but we didn't bother to build indices on the last name and the first name, gosh, if it's got to sort that list every time, wouldn't it be faster if we built those indices? It would. Now, the thing to remember about an index is once you build it, every time you update, delete, or insert a record, as it does that update or delete or insertion, it has
connection's going again.
Sorry. Let me know when we're back. Are we back now? Am I with you? Can you hear me now? Are you with me, Wendy?
Yeah.
Okay. So the point being is that if you build the index, it requires care and feeding. Every time we make a change to the database, the index has to be updated. So you pay for performance in drips and drabs. Okay. So we don't just create an index on everything, whether we will actually use it or not. We think very critically. Will an index on this help me a lot about in the things that I do most on the database? Okay. And so as a matter of fact, when we get into really advanced database classes, we will do things like using a wired index. What do we mean wired? Wired into memory says this index must not be stored out on disk. I want you to take this index when you load, Mr. Database Engine, load it entirely into memory and keep it there and update it there, because if I don't have to go to secondary storage or hard disk, RAM is going to be the fastest possible way. But think about it. An index could be really big. It could eat a lot of your RAM. So there's a trade-off between, I can get great performance, but let's make sure that it's really that important, because I'm paying pure gold for it. I'm paying in terms of resources that I don't have a lot of, which is RAM, core memory. So there are things like that that are really kind of advanced database stuff. Boy, if you learn database stuff at that level, you're going to be a six-figure DBA. And it doesn't take that much to learn it at that level, honestly. The fact that we're having this conversation and you understand it says, oh, I get what we need to do. Now all I need to do is learn the technique. That's exactly right. Okay, but it's the difference between a 60, 80, $90,000 a year DBA and 120, 130, $140,000 DBA, or somebody who gets into what we call, like a data architect, the person who helps plan the entire systems and layout and databases for an enterprise level organization.
Right.
And that's cool. I mean, if you like doing that kind of work,
Mhm.
if you did getting that kind of dough, I mean, that's good pay. That's a good gig, and you can do that. If you're interested in that, you probably ought to start looking at classes beyond what we offer at a two-year university, and also look at some of the professional certifications. We can help you get started on that, though.
Yes, please. Yeah.
Yeah, absolutely. Talk to our department chair, Esther Frankel.
Esther, right.
She has access to a lot of the, I'm trying to think of the name of the
Transgender.
transgender, the
Yeah.
transgender exams, and so we can arrange for you to take the practice exams, often at no cost if you're a current CIS student. So
Yeah, I did that in Kathy's class for the Linux class, so that was
dynamite.
good. Yeah.
Good. Yeah. So that's those exams are helpful. The certifications are helpful. Although every certification sinks its teeth into you because they have to be maintained with continuing education. So you pay a little tax for every one you acquire. So choose wisely.
Yeah, I'll probably be picking your brain about that because I do want to go for what's going to be the most valuable. So
There's lots of good ways to go, and everybody's going to have an opinion. I'll be happy to give you mine for free.
Thank you.
But remember that my opinion, yeah, it may work for some people at some point in time. But at least I will give you my thinking as to why I think this would be a good way to go, or at this point in time. And a lot really matters in where do you want to work. If you're going to live in Santa Barbara, or where are you living currently?
I'm in Napa. Okay,
if you want to continue to live in Napa, you better go with whatever products, I don't know, major wineries and vintners are using. Because what else is there in Napa? I don't really know.
Okay.
I
can't travel to the Bay Area.
Okay. Now the Bay Area, if you're going to live in the Bay Area, or you're going to commute in the Bay Area, now you're in a major metropolitan center. You ought to be looking at Oracle. Okay.
Right.
And that's because, but where I am in Santa Barbara, we have Oracle classes on the books, and we seldom teach them because most of the shops, the employers regionally in Santa Barbara, they're either a Microsoft shop using SQL Server, or they're using open source software like MySQL.
Right.
And so, it's tough for me to fill a class with 35 students that want to learn Oracle that are in the Santa Barbara area. So
it doesn't seem like it's that different. I mean,
no, it really, most everything is analogous, and there are some proprietary differences. And that's where you really want to get into the certification training anyway, because that's where you're going to focus on those kind of distinctions. But what you will find is that even in the things that are distinctive, so for instance, the procedural aspect of the PL SQL language, there are comparable constructs for every one of them, almost every one of them, in the SQL Server Transact SQL dialect, and vice versa. They approach some things differently. Each one does some things a little bit better performance-wise than the competition, and of course they're always looking to double down and try and improve what they do over what their competitor does, and that's their competitive advantage. But for the most part, just understanding the common ANSI SQL is going to be 80 to 90% of the job most of the time.
Right.
All right, so this is one way to look at what's going on with this. It really would have been nice had it told us what is the combined this query running on this query, because when you think about it, this query is running on the view. What is a view? A view does not store its own data. There's a rare exception called a materialized view, again, advanced stuff. But most of the time, all this means that the SQL compiler has pre-compiled this query. That gives you a little bit of a performance advantage. But other than that, this is just a query. It doesn't really exist as a table. So this is a query on a query. Right. And so what we want to do is, again, let's take this whole thing and wrap it in, actually, let's take this whole thing and wrap it in a hug, because this is what we're acting on. So I'm going to get rid of the create view. Here's our original SQL that created the view. If I take this whole thing and wrap it in a hug and say as my query, right? Okay, so here's this my query thing. Now, if I copy that, everywhere that I see the name of that view, so here is the name of that view. What if I put that whole thing there? Is there another place where it appears? Yeah, here is that view. What if I put that whole thing there? Now, could it be just that easy that wrapping that whole thing so it's one big blob of SQL? Now it's working not on the view, but it's running on its own internal thing. Does it work? Son
Oh,
of a gun. It gives us the same exact issue, same
yeah.
exact results. There it is. There it is. So everywhere that I referenced the view, I just replaced it with the entire SQL expression that defined that view. And let's prove now, how can we prove that we're not actually using that view? Well, let's come over to the view on, let's see, is this the 117 database? Here are the views. And let's see, let's refresh it. And item gross profit, if I take and drop that view and delete it, it's gone. So now it can't possibly be using that view, right?
Right.
So now if I take that, there can be no mistake and it still
Yep.
runs.
Yep.
So yeah, and that is that. Now, if you want to see how the whole thing works in your execution plan, we could come here and say, show me the estimated execution plan, and now you can see the whole thing working together. And one
The
of the things,
sort cost instead of 0 is now 51. Yeah.
yeah.
Yeah, look at that.
So here's a sort that is costing us a lot. And so one of the things we might take a look at is where is that sort occurring, and why does that, is there an index that we could build on it that would make it run faster?
Mm-hmm.
And if you take the 107 class, or even actually we did some of this, I think, in the 243 class. I'm trying to remember if we have a little performance exploration there.
It was either 243 or 107. Yeah, I can't remember, but we did. Yeah, have
Yeah,
something.
and so we'd say, how does this run if I don't have the index built? And then, what if I do build the index? Again, that's kind of beyond the scope of this class, but there's some foreshadowing and some things for people who want to go above and beyond and understand how this stuff works. You can see, and this is one of the tools we would use visually to help us analyze. As a matter of fact, you might be asking yourself, hey, if it can do this, why can't it have a tool that is so intelligent that it automatically analyzes and recommends, if you were to build this index, this query would run.
Yeah.
Okay, rational rows, database design tools are out there. They tend to sell anywhere from $1,000 to $10,000 a seat.
Ooh.
But they do help replace having a really intelligent DBA. My recommendation is have a really intelligent DBA who knows how to read this stuff, and then then if you want to get them a $10,000 tool, that's totally cool. that will make them even better. But don't take a DBA that doesn't quite, hasn't really studied what's going on, and give them a tool where, because again, if we build the index, it costs us something. Was
Right.
it a good trade-off? And you need to understand enough about what's going on to go, hey, in terms of the processor we have, because if I get to the point where I'm choking off our CPU, because all the CPU power we have is used up because we have so many indexes, or so many things in RAM that are eating it, was that a good trade-off? Well, no, not if you have to do $1 million data center upgrade.
Right.
On the other hand, if you have hardware that is underutilized, why the heck not tune your application to use, more of it so that you get better performance? Again, as long as that performance buys you something in terms of business advantage, time or money, or efficiency. Because it doesn't. Don't be. What does stupid look like? Stupid is going to the circus buffet where you can get all you can eat for $20, and giving them $40 and say, I'd like to have $40 worth because I'm like really hungry. Well, no, it doesn't make sense, right? It didn't really help you. If your database, if your query is running in under 10 seconds. And in order to, you're telemarketing and you're dealing with a customer, and the customer is generally talking with you for more than 10 seconds. Do you need to make that query faster? No. Okay. However, if you have somebody who's clicking through a website and at the end of 5 to 8 seconds, they are leaving your website if they didn't get a result back.
I've done that.
Okay,
Yep.
now the cost is justified to get it down by the extra few seconds. So,
Right.
we got to make good business decisions. And again, now we're getting over into the CIS 243 and systems analysis kind
Right.
of stuff. But you can see how all these classes kind of fit together. All right. So we've kind of gone way over time, and I'm totally happy to do that. The question is, we've gone through 3C. Have we answered all your questions? Or since we're here, shall we see if we can put 3D to bed as well?
I'm going to say, okay, so we've got 2 tables.
2 tables does not actually stop you from having
No, I know.
it updatable, as long as both primary keys are there, and there are,
Right.
if there are no missing fields that are null constrained, it is possible to have
Yes.
2 or
Yeah.
more fields. But there are a couple things here. We got 2 fields. Do we have in the select list in the display? Do we have the primary key from each of the tables? I got item ID.
Yes.
But do I have what's the primary key for the other table? I don't have, it's not in the select. So it's not going to be updatable.
Okay.
But there's a better reason. We could say another reason, but to me, there's a more immediate reason. Do you have an aggregate function?
Yes, you do. Yeah, so that's going to be
If
the
there's an
number
aggregate
1.
function, it's not, do you have a calculated field?
Yep.
Okay, if you have a calculated field, if you have an aggregate function, not updatable, because
Right.
calculated fields aren't stored anywhere. Okay, so
Right.
what would an update to that look like? The database would have to somehow know how to decompose that number into its constituent parts. That's magic. It doesn't happen that way.
Right.
Right, so we can get the constituent parts and give you the aggregated field, the result, but we don't store what that calculation was, so it's not going to be able to decompose and put those pieces away. So right away, so there are a lot of full credit answers, but to my mind, the best answer would be something like, hey, professor, this is not updatable, first and foremost, because it has a calculated field. Secondly, because it has an aggregated function in it. And then, just additionally, the coup de grace is that it doesn't have the primary key for all of the base tables present. And how can we, and got to be careful, there's always a tricky answer. Is it possible to do an insert on a table without providing it the primary key? And at this point, you're like, no. And I'm like, yeah, actually there is. And that is, there is something called an auto key. Okay, we can have a primary key automatically generated using something called a trigger on the insert, and it will use another database thing that we haven't talked about called a sequence. A sequence keeps track of the last number used. So if we're using an integer sequence 1, 2, 3, 4, 5, and I have 5 records, the next sequence number is going to be 6.
I'm familiar with the sequence, right? Okay.
Right. You can also thin the sequence out and say, I want sequence skip 5. So it'd be 0, 5, 10, 15, 20, 25, 30. Okay. So it generates a little sparseness in the keys. There are reasons why you might want to do that. But if you did that, yes, it could generate the key automatically, which could be a way to overcome the fact that the primary key is not in the view. And
yeah, I think they read that wasn't really recommended, though, if I remember.
No. By and large, as far as if we're talking recommended, it's very strange to ever do updates through a view. There can be reasons for it, and I want you to understand when it is and isn't possible. But for the most part, doing updates through a view is or inserts or updates, either one, or deletes. It's just not something we would typically do.
Okay, now how about distinct? Because that was treated as kind of like a calculated field or an aggregate. It said that you can't update when you use the distinct operator.
Right, because distinct is hiding, it's filtering some of the results.
Ah, okay. That's kind of what I was thinking.
So can you insert? when there's distinct. Yes, you could insert, but you can't update
Right.
and you can't delete, because if distinct is hiding one of two results that are, insofar as those results are returned identical. Now remember, there's primary keys and whatnot, so there are different. There's going to be some distinction. It just may not be shown. I can do a partial. Select only some fields and make it look like rows are identical because we didn't include the primary key. And it may be the only thing distinct is the primary key. The primary key may be like a serial number or a GUI ID. And so you have two things that are otherwise identical. They're not fully identical. So if the distinct keyword is getting rid of duplicate results, when you say I want to delete this, which one of the two or more are you deleting? Or are you deleting all of them? And did you really mean to delete all of them? Wait, that's too dangerous because you don't really know when you have distinct turned on. So the safe thing is to say, no, we're not going to allow it. If we're using a distinct to form the view, not going to happen.
Got it.
So yeah, so you can kind of just talk through that one.
Okay, cool.
Other questions?
I sent you something in the email about number 4. Right now, I think I'm done for the day. So.
Okay. Do you want to hang? You can watch the recording later. You want to take a quick look and just I'll run you through number 4 very quickly.
I got the select statement down for the number 4, but all I'm getting is the column headers. I'm not getting the data, so it's like.
Okay. So number 4 is there's pick lists and pack lists in a warehouse operation. Pick list says go pull this order. You go get the material from the warehouse and you put it into a bin. Then it goes over to packing, and packing takes and reconciles the things that have been picked with the customer information and puts it out, packages it up and ships it, and with the shipping is usually typical where we release the billing. So as soon as that thing is on the truck, we want to bill the customer's credit card number. So for a couple reasons. One is that's the earliest point at which we legally can. And secondly, we don't want them to cancel the credit card while the thing is, I knew people that used to, I don't know if you bought Apple products early on made in China, and when they were being shipped from China, you could watch them being shipped. I knew of a couple unsavory folks who would wait until they got the shipper, they saw it was on the boat, and then they'd cancel their credit card, and so the transaction couldn't complete, but the product would be delivered. That was I
never even thought you could do that. Wow.
They pretty much figured out how to put it into that early on, but yeah, that was it. So we're going to create a pick list, and let's start with select star from some tables where something. So we know that's our pattern. What tables are we going to need to get a pick list? And if we think about that, we're going to need in the pick list, we're going to need orders.
And order details.
And we're going to need items, but we can't go directly from orders to items if we don't have the order details, exactly like you say. Okay. And again, at this point, if I were to run this, we would get some big, ugly, probably ought to tell it. I've still got stuff up here. Sorry, forgot that. Okay, and again, 31,960 rows ought to tell you that you failed your sanity check. And so what have I done? Cartesian product, I've blown my join. So I need orders dot something equals, and what is orders going to relate to? Orders to items, orders to item details. We can go back and look at our entity relationship diagram, and it goes orders to order details to items. Yeah. Orders to order details to items. So order to order details and order details. You can almost see, once you learn the pattern, it's almost like a formulary for doing this, equals items dot something.
Yeah, that helps looking at the diagram, because I just look in Object Explorer and I kind of go down, but then sometimes you have to kind of jump back up. So that I like that tip.
Once you're using the same database you've worked with for 10 years, I mean, you see it in your sleep, honest to goodness. But until you are there, then having the ERDs, and every DB I know, the group has a war room, and in the war room there are e-size plots of, because these are amazingly simple data models,
Right.
4 tables. Okay, major systems often have a couple thousand tables. Okay, so. But a lot of it is like really, weird stuff, like the lookup table for all the two letter state abbreviations as a lookup table. Okay, I don't really care, right?
Yeah.
But it's one of the tables that are out there, so you don't really often get involved in that. But there's a lot of other things. Yeah, there's your core tables, and there may be only a dozen or a couple dozen of them, but there are a lot of ancillary things that because a big enterprise system. We throw a lot of junk in there. It relates to a lot of ancillary systems over the years, some of which go away, some of which,
Do they have people that
replace.
just work on certain tables, certain core tables, and?
Yes, in a
Okay.
big DBA group, you absolutely, when I was at Atlantic Richfield, I think we had about a dozen people in our DBA group. Okay,
Wow.
that's just doing database stuff. Okay,
Wow.
and there were different systems and different engines. We had a big IBM database, DB2, and we had some SQL Server databases, and we had some Oracle databases, and so various things, and they kind of divvy up the work. But it's not unusual for on an enterprise system, something running SAP or PeopleTalk or Oracle Financials, where you have really large systems. You might have multiple DBAs just dedicated to one particular system. And when you are the one who works with that data dictionary day in and day out, you kind of become the subject matter expert for it. So that's not at all uncommon.
Okay.
So we've got to figure out what these things are what are the bridging. So order to order details, it's probably something like, and this is where IntelliSense is really helpful if it's working.
It's going to be orders.
Orders.
Yeah. And that's what, order ID? Or was it item ID?
Well, in the orders table. So again, we can
order ID.
we
Right.
can cheat.
Right.
And so it's going to be order ID.
Order ID. Okay.
And equals order details dot order ID, and then order details to items. Now we're going to be talking about the item.
Right.
I think it's item ID. Let me take a quick.
It is. Yeah.
Yeah. And items dot item ID. And again, all of this so far is just to get the join done. Okay, and I've got something. Show me. And here's the line where orders dot order ID, order details, order ID. Let me take a quick look. One of the ways we can check our names, if I come and expand out the column names.
That's what I usually do.
Order underscore ID, order details. And is it orders or order? Take a look at
It's
our
orders.
tables. Okay, yep. Why is it being picky about that?
I don't know.
From these tables. How about we add a where clause in there?
Oh, God.
Oh, and look, now my. Okay, so give that a shot. And now we have the whole mess, and it's working, and 68 rows. Now that passes my sanity check. Okay, and then what else were we doing on the pick list? We need a filter. Okay, we can trim this down because we only need certain fields, and you can look at the criteria. I'm going to leave that as an exercise for the student, but let's add another. What do we want to do? Which one of these do we not want? And we don't want it where the ship date is what? Null. If I haven't shipped
I
it,
thought we did want null, because don't you want orders that weren't shipped?
oh, I'm sorry. We don't want it where it's not null. We only want, because the pick list, we're only picking for, we're not duplicating orders that have already been filled. So we want it for, you're right, ship date is null. And shipped date is null.
Oh my God. Okay, so that's where I went wrong. I put ship date equals null. Ah. Okay.
This is the easier way. There's a way to do that. This is the easier way, is just using the is
Yes.
null operator. So now all I have are those items. And so as an exercise for the student to complete this, what you need to do
Right.
is just come in here
Yeah, I
and,
got that part. Yeah.
you know, get rid of the star and put in
Yeah.
the exact fields that
Okay.
you need for the pick list.
Okay.
Okay. So now you should be able to knock out number 4 pretty easily.
Yes. Thank you. God, it's the stupidest little things, I swear.
It's always the small stuff. It is always the small stuff, and that's also why it's, you know, it's really nice to be working in a larger shop, because sometimes what you need are new eyes, and you can go, you know,
Yeah.
Peggy, would you look at this for a second? Because I just have been banging my head, and Peggy comes over and goes, "You fool," you know, and they look at it in 10 seconds, they realize, you know, I don't know why I didn't see that, and then
Yeah.
later that afternoon, Peggy goes, "John, would you come take a look at this? Because I've been banging on it," and you go like, "Well, what about this?" And they're like,
Yeah,
"Okay."
and I find it helps if you step away for a while.
Yeah.
You know? Yeah.
New eyes, whether
Yeah.
they're your own or somebody else's.
Yeah.
You know, take the coffee break or the chamomile tea break, depending on what's best for your health, and you know, come back to it in a few minutes. All right.
Got
So,
it.
all right. I think we'll end it there, unless you have any other questions or pressing
No,
issues.
I think I'm good. So I hope so. I should be able to finish things up.
I'm
Thank
glad
you
to hear
so
it.
much, and thanks for going the extra time. I'm glad nobody else showed up, sort of.
Yeah, might as well use the time if nobody's there. And
Yeah.
I did have a couple other people that had emailed me about this, so they'll be happy to see a thorough discussion of it in the video. So that'll work out
Okay,
great.
they'll have to sit through all the other stuff, but okay.
No, actually, because remember, in YouTube, you can do a couple things. One is you can download the transcript and search the transcript in your word processor.
Oh, I forget about that.
Number two, you can tell it, you know, turn on the closed caption and turn the
Right.
speed up to double speed. So if it's an hour, you don't have more than 30 minutes to go through. Plus, you know, pull the little wiper bar across in 2 or 3 minute increments. Go, yeah, that's not. Oh, there's the part I'm interested
Well, I
in.
can do that now with my new computer. I couldn't do it with my old one. It was like, oh my God, yeah. And if I had to go back and listen to it again, it was like, Yeah,
Sorry.
great.
Yeah.
Thank you so much, Professor Beck. I really appreciate it.
You're very welcome. You have a lovely evening.
Thanks, you too.
All right.
Good
Bye
night.
now.